Welcome, students. Today we venture into the captivating realm of motion in two dimensions. While motion in a straight line explores the movement along a single dimension, motion in two dimensions allows us to study the intricate paths traced by objects moving in a plane. In the world around us, objects rarely move in straight lines. We often encounter motion that involves both horizontal and vertical components, such as the flight of a projectile or the path of a bouncing ball. To understand and analyze such motion, we need to consider the concept of motion in two dimensions. When an object moves in two dimensions, we describe its position using two coordinates, usually denoted as x and y. The x-coordinate represents the horizontal position, while the y-coordinate represents the vertical position. By tracking the changes in these coordinates over time, we can map out the object's path and analyze its motion. Just like in one-dimensional motion, we have displacement in two-dimensional motion. However, instead of a single displacement, we now have two displacements, one in the horizontal direction, dx, and one in the vertical direction, die. These displacements allow us to determine the change in position in both dimensions. To understand the overall motion of an object in two dimensions, we introduce the concept of velocity. Velocity is a vector quantity that combines both magnitude and direction. In two dimensions, we have both horizontal velocity, Vx, and vertical velocity, Vy, which represent the rates of change of position in the respective directions. Velocity allows us to determine how fast an object is moving in each dimension and in what direction. Similar to velocity, we have acceleration in two dimensions. Acceleration is the rate at which an object's velocity changes over time. In two dimensions, we have both horizontal acceleration, ax, and vertical acceleration, ae. These components of acceleration help us understand how the object's velocity is changing in each dimension. Now, one of the fascinating aspects of motion in two dimensions is the ability to separate the horizontal and vertical components of motion. We can analyze the horizontal and vertical motions independently and then combine them to determine the overall motion of the object. This approach allows us to break down complex paths into simpler components and gain a deeper understanding of the motion. To describe the motion of objects in two dimensions, we often utilize mathematical equations and tools such as vectors and trigonometry. By using vector addition and subtraction, we can combine displacements, velocities, and accelerations in both dimensions to obtain the resultant quantities.